All right, here we go. Algebra 1A, we're looking at a quiz on simplifying and evaluating algebraic expressions. We're doing version 1 of this quiz. I'm just going to do problems 1 through 8 on this video. But yeah, it can be a little tricky sometimes. So a few things I want us to remember is that in this case, with these expressions here, we don't know the value of the variables. We don't know, like number 1, we don't know what x equals. We don't know the variable values. Never tells us that x equals 7 or x equals -2 or something like that. But also, we don't know the variable values. We also don't care. Our goal is not to come up with an answer that says x equals 7. Our goal is to simplify. All right, so we're just going to do the operations we can do. And one other thing to remember is that as we do the simplifying, we need to keep order of operations in mind. So I'm going to reference that. I'll refer to that. Order of operations is still going to be important. So here we go. Number 1, 9x minus 6x minus 4. So if I'm looking here, these are just terms that I'm trying to add. So first thing I might do is I might chop slash this. I might say that's really plus a -6 plus a -4. So if I do the chop slash here, so that's also important, so we keep that in mind. But now I'm looking at like terms. So I say, all right, what do we have for like terms? And in my silly story, I'd say something like, I have 9 xylophones plus I owe 6 xylophones plus I owe $4. But we can take the 9x plus the -6x. And remember, you get to use a calculator here. So if you need to, 9 plus -6, that's a +3. But that'd be my xylophones. That's x. So that takes care of the 9x and the -6x. And then the -4 doesn't have any other like terms with it. So a -4 would just is by itself. Okay? Now, if we put these back together, again, in my silly story, I have 3 xylophones and I owe $4. You can either say 3x plus -4, or the way that most people would say it, they would say 3x minus 4. But it's the same thing. You could also say -4 plus 3x if you wanted to. Okay? But a common way to do this is 3x minus 4. So just combining those like terms. That's done. We don't do 3 minus 4. It's not -1x. You have 3 xylophones. You owe 4 xylophones. Number 2, very simple there. It's just you have a yo-yo and you owe a yo-yo, or you owe 10 yo-yo, excuse me. So if I rewrite this, if I do the chop slash, we could say it's y plus -10y. You could also say that's 1y. So you have a xylophone plus you owe 10 xylophones, or yo-yos here, whatever. But that's just going to give you -9y. That's it. So that one's pretty simple. Let's keep going here. Number 3, we can think about our like terms. First of all, I can do some chop slashing. Let's do that. Plus 8 plus 5c. This is a really tricky one. Some people think that the subtraction belongs with the 2. I go, no, the subtraction belongs with the 3c. So if we chop slash that here, let's chop slash that plus a -3. So now if I'm looking at my like terms, you can tell yourself a silly story if you'd like. Maybe it's you have $2 plus you owe 3 carrots plus you have $8 plus you have 5 carrots. So I'll look at the variable first. We owe 3 carrots plus we have 5 carrots. So -3 plus 5, again, use a calculator if you want to, but that's a +2, and that would be carrots. That's the variable. Okay. And then what's called the constant term is the numbers that don't have the variable. So that'd be the 2 plus the 8. And that's going to give you a 10. Now, in my opinion, the hard part's over, but we just have to put things back together. I have 2 carrots and I have $10. And we're done. It's not 12C. It's not 12 carrots. It's 2 carrots and $10. Again, if you wanted to say 10 plus 2C, you could do that. I don't care which you do first, but most people would put the variable first. Okay. Number 4 is where it gets a little tricky here now with those parentheses. Remember, we want to follow order of operations as much as we can. So we should really start here. We should say, let's not worry about that 7 yet. 7 is outside parentheses. Let's think about 6m minus 5 inside the parentheses, inside the group. But there's nothing to do. I can't perform 6 times m and then subtract 5 unless I know the value of m. So this is where we have the loophole. We have the way around it. And my silly story is the baskets. So I would say I have 7 baskets. Okay, I'm going to rewrite this. I'm going to chop slash. But that would be my silly story. That's how I try to make sense of this. So instead of minus 5 plus negative 5, but I've got 7 baskets, and every basket has 6 melons. I don't know. So, okay, well, I don't really care about the baskets in the end, but I can do, there's 7 baskets and there's 6 melons in each basket. So that would be 7 times 6m. That's going to give me 42 melons. I'll fill that in here in a moment. But then I would also have in my 7 baskets, each of those baskets I owe $5. So 7 baskets times we owe $5 per basket. So that's the idea. And then I can do that multiplication. That's going to be 42m, 42 melons, and then plus we're going to owe $35. The only thing I'm going to do here, that's fine for me, by the way, but I'm just going to write this as 42m minus 35. But that's it. We're done. 42m minus 35. And again, if you wanted to say negative 35 plus 42m, that's okay also. But yeah, that's it. It's not, what would that be? 7. 42 minus 35 is 7. It's not 7m. It's 42m minus 35. So that, by the way, is called the distributive property. That's the technical term, the distributive property. And if you've had me in class, you might remember that I call it the wink and smile. So that's where we're supposed to do 6m minus 5 first, but we can't. So we have this little loophole. The distributive property is a loophole that lets us still do some operations, even though we can't do it in the prescribed order. Okay. All right, we got 4 questions left. 5 is a tricky one. Be very careful here. I'm going to rewrite it. I'm going to sneak in a 1 in front of the parentheses. So I'm going to sneak in a positive 1 right there. We know that we can always multiply with a positive 1. But then I'm also going to chop slash. So I'm going to say it's 12n plus negative 1 times the parentheses, and in the parentheses 7 plus negative 3n. So again, follow order of operations. We're supposed to start here, 7 plus negative 3n, but we can't do that. So what would come after the parentheses, after the grouping symbols? Exponents, but there are no exponents. Next would come multiplication. So I'm going to multiply the negative 1 times the parentheses. So that 12 is just going to wait its turn. 12n is going to wait its turn while I distribute the negative 1. So I'll do negative 1 times 7, and then negative 1 times negative 3n. Okay, and I'll scoot my work up here. So that becomes then the 12n is waiting. Let's see here. Plus negative 1 times 7 is a negative 7 there. And plus a negative 1 times negative 3n, that's going to be a positive 3n. Okay. And now I can combine my like terms. If I'm telling a silly story, now I'm at, I don't know what n would be, napkins. I got 12 napkins. I owe $7, and then I have 3 napkins. So I don't have the space like I did on number 1 and number 3 to write like terms, but that's the idea. We're going to put our like terms together. So 12n plus 3n is 15n, 15 napkins. And then we owe the $7, so plus negative 7, and that's it. We don't combine those. Again, I'm going to write it as 15n minus 7 that's up to you. You could also say -7 plus 15N, but it's 15 napkins and we owe $7 and we're done. We don't combine those. It's not 8N. It's not 8 napkins. All right. Number 6, same idea. We're going to try to follow order of operations. We have something in parentheses, but we can't do it. We can't do 2 plus 3H, but we can do 6 times 2 and 6 times 3H. We can wink and smile. I'm not doing 6 times the 8H, by the way, because the 8H is not in the parentheses. So that just comes on down. If I was telling a silly story, I would say I have 6 baskets. Each of those baskets has $2 and 3 hamburgers. And then there's another 8 hamburgers outside the baskets, outside any of the baskets. So $2 in the 6 baskets would be $12. 6 baskets, each basket has 3 hamburgers. That'd be 6 times 3 is 18, and that's hamburgers. And then plus the 8 hamburgers. And now I can combine my like terms. I can say, hey, the 18 hamburgers and the 8 hamburgers, that's going to be 26 hamburgers. And then we got the $12 also. So again, that's the standard way to write it. If you wanted to say 12 plus 26H, that's what you'd have. But we're done. Again, it's not 38H. It's 26 hamburgers and $12. It's not 38 hamburgers. The 26H and the 12 are not like terms, so we just leave them separate. Okay. 2 more. Let's see here. First thing I'm going to do on number 7, I'm going to chop slash that -4. This is a very tricky one. Number 7 is a very tricky one. So I'm going to chop slash the -4 plus -4. I'm still trying to do order of operations. 2W plus 8 in the parentheses in the group. Can't do it. It's 2 watermelons and $8. So I can say, well, you've got the multiplication. So this is the common mistake. We don't combine the 11 with the -4. Not yet, because that would be doing addition or subtraction before we multiply the -4 with the parentheses. So that's a common mistake. So we're going to distribute that -4. So we'll do -4 times 2W. The 11, by the way, is waiting its turn. The addition or subtraction is waiting. That's going to be last. We're going to add -4 times the 2W. And then that's the wink. And then we're going to add -4 times the 8. That's another mistake. People do 4 times 8. I go, no, it's -4 times 8. Chop slash. If you do the chop slash, you help yourself remember that it's a -4. All right. So let's see. We can do -4 times 2W. That's going to be -8W. And -4 times 8 is -32. And then we can combine our like terms. It's $11. I owe 8 watermelons maybe, and I owe $32. So this is the only W. So I like to start with that. But then for the dollars, I have 11 plus I owe 32. That's going to make it, what is that, -21? Okay. And then I would just write this as -8W minus 21. You could also say -21 plus -8W. You could say -21 minus 8W. These are all the same. It's just standard to start with the variable and instead of saying adding a negative, just to say subtract. But it's fine with me if you say -8W plus -21. Okay. All right, we got one more here. Number 8. If we follow order of operations, I should start inside parentheses, either do -3A plus 8 first, do A plus 10 first, work inside the parentheses, but I can't do anything with -3A plus 8. I can't do anything with A plus 10. So since I have the multiplication by the parentheses, I can distribute. I can do 4 times the -3A. There's no chop slash to do here, by the way. There's no subtraction. Plus 4 times 8. I can wink and smile with the 5. So add in here 5 times A, 5 times 10. And then remember, multiplication doesn't care about like terms. So you might say, well, hey, the 4 and the negative 3a, those aren't like terms. And I go, right, but we're multiplying them. I can say there's 4 baskets and I owe 3 apples for each basket. Okay, so you're going to owe 12 apples, negative 12a. 4 times 8, that's that's a positive 32. 5 times a, we just write that as 5a. And 5 times 10 is 50. Okay. And now I'm down to just combining my like terms. So if I start with my variable, I owe 12 apples and I have 5 apples, so I'm going to owe 7. You can do negative 12 plus 5 on the calculator if you want, but that's apples, that's A. And then 32 plus 50 is going to be 82. That's a positive 82. So yeah, you can leave your answer that way. If you wanted to say 82 plus negative 7a, you could say 82 minus 7a. That's all good, but I like negative 7a plus 82. So there we go. There's section 1 through 8. I know it can be difficult, it can be challenging, but practice, practice, practice.